Good morning, all of you. We are discussing about the overlapping, types of overlapping. Already we discussed SS overlapping. The second one is SP overlapping. So SP overlapping means is a overlapping in between S and P block elements. Compulsory one S block element should be there, one P block element should be there. S block means the last electron should enter into S orbital. P block means the last electron should enter into P orbital. Okay, for example, AB overlapping. A atom coming with the S orbital, spherical shape, nucleus, positive charge, single electron. B atom coming with the last shell A orbital with the nucleus, positive charge and electron. They are intermixed together. Then between A and B, we are getting a pair of electron carries negative charge, had strong force of attraction with this nucleus called as a bond. So anyway, the AB bond is formed because of S orbital of A atom and P orbital of B atom. So can you give us some example for the SP overlapping? Is nothing but HF, HCl, HBr, H, S block, P, block element is fluorine, chlorine, bromine, iodine, water, S, hydrogen, and from oxygen, P orbital. Like that, from hydrogen, S orbital, from nitrogen, P orbital. That's why bonds are formed by SP overlapping. Just I will give you one explanation. You can see HF molecule, H and F. Just you see hydrogen is a single electron, 1s1. Fluorine atomic number 9, configuration 1s2, 2s2 and 2p5. You know very well the valence shell orbital with single electron only involving in the overlapping. You can take 2s is having 2 electrons, 2p out of actually 3 times, yes or no? Out of 3, first one goes into each orbital, then only pairing takes place. From fluorine, which is ready to involve in the bonding, a last shell, a single electron having orbital, nothing but pz. So that's why from hydrogen, s orbital, and from fluorine, p orbital is coming. So they are coming with single electrons. They are involving in the overlapping of hydrogen and fluorine. Yes, after that, between hydrogen and fluorine, we have a pair of electron that is formed because of HF bond SP overlapping. And you can see the last category is nothing but PP overlapping. PP overlapping. I think you can guess it among. Just what is the meaning of PP overlapping? Is the intermixing of atomic orbitals of two atoms is nothing but p orbitals. So that means is always overlapping is happening in between p block elements. P block elements. Why? Because p block element means is nothing but element last electron should enter into p orbital. That's why the p orbital only involving in the overlapping with another atom of the p orbital. Then it is calling as a pp overlapping. Can you give some example for this one? For example, both the elements should be from p block only, like Cl2, Br2, I2 and F2. These all are under concept pp overlapping molecule. Just I will explain for the F2 molecule. Already we know from each fluorine which is involved in the overlapping to pz orbital. That one I am showing you. From each fluorine to pz orbital with single electron. From another fluorine also we have one more p orbital from last shell with the unpaired electron. They are involving the overlapping. Are you clear or no? Yes. Then what you are getting? Yes. Between two fluorines we are getting a pair of electrons. We are getting carries negative charge. Nucleus carries positive charge. This positive and negative charge are having attraction force. That's what we are calling as chemical bonding. So between fluorine and fluorine we have a single bond. So like that we have SS overlapping, SP overlapping and PP overlapping. So we are discussing the very important concept. Listen carefully, all of you. Is nothing but types of covalent bonds. Types of covalent bonds. So already we discussed the types of the covalent bonds like polar and non-polar based on type of the shape. Now again we are classifying the covalent bonds into two types based on type of overlapping. Based on type of overlapping. Yes, you see the concept is very important for all aspects like board and like competitive examination. Based on types of the overlapping, covalent bonds will be classified into two types. One is a sigma bond denoted by like this, and another bond is nothing but pi bond denoted by symbol is like this. So based on type of the overlapping, the covalent bonds will be classified into two types, sigma bond and pi bond. First of all, we are explaining about the sigma bond. Yes. Anybody know what is the meaning of sigma bond? Do you have any idea? Right now you haven't any idea, just I will tell you, listen carefully. Sigma bond. Just first I will write the definition. Sigma bond is the covalent bond formed by so internucleus overlapping of atomic orbitals. A covalent bond is formed by the overlapping through its internuclear axis. Such overlapping gives a special covalent bond is calling as a sigma bond. Sir, what is the meaning of internuclear axis overlapping or atomic orbitals is involving in the overlapping through its internuclear axis? For example, I am taking one atom A is having, for example, s orbital with a nucleus with a single electron. Now B atom is there, B atom having, for example, p orbital from its valence with a nucleus with electron. What is the meaning of internuclear axis? So if you can take this nucleus of A atom and B atom, if you can join and if you can imagine one line by passing through the nucleus of the two bonded atom, that only we are calling as internuclear axis. Now the two atoms are approached together through its internuclear axis, then what happening? One of the atom of orbital will be overlapped with another atom of the orbital, then we are getting overlapping. The overlapping gives a bond that is calling as sigma bond. After that, what we can tell, you know very well. Yes, we are getting like this huge area, we are getting, this is related to A atom of the nucleus, positive charge, is the B atom of the nucleus, positive charge, and like this will be there. And after that, we have a pair of electrons we are getting. So after that, what we can write clearly, between AB atoms we are getting a bond. So the bond is having a pair of electrons on it. That bond only we are calling as a sigma bond. Can you tell me one clarity regarding sigma bond? The sigma bond is a covalent bond which is formed by overlapping of atomic orbital through its internuclear axis. Means the two atomic orbitals should be come on to the internuclear axis, then we are getting a covalent bond is calling as a sigma bond. Okay, now later we have to discuss some other things. The sigma bond is formed by two types of the overlapping. Next point is also calling as head-on overlapping, or why? Head of one atomic orbital and head of another atomic orbital is intermixed. This is calling as head-on overlapping, or also calling as end-on overlapping. One atom of the end, another atomic orbital of the end will be overlapped together. This is overlapping is calling as head-on overlapping or end-on overlapping. After that, we can see some other things. These sigma bond is formed by three types of the overlapping. One is SS overlapping will give sigma bond, and SP overlapping gives sigma bond, and PP overlapping will also gives the sigma bond. Sir, how? Yes, S orbital means like this, and one more S orbital is like this. Through its internuclear axis overlapping is happening, we are getting a sigma bond. And from one atom S orbital, from another atom P orbital, and through its internuclear axis is overlapping, then we are getting a sigma bond. Not like that, p orbital of one atom and p orbital of another atom is approached to its internuclear axis, then overlapping is happening, we are getting a sigma bond. So sigma bond is formed by overlapping of SS, SP and PP overlap. See, we will see some other characteristics of the sigma bond. Listen carefully. The sigma bonded electrons is called as a localized electrons. Sir, what is the meaning of localized electrons? So in case of sigma bond, what we can tell, the bonded electrons is lying or present on the internuclear axis, means they are having a particular location. That's why called as localized electron. So the sigma bonded electron is present on the
internuclear axis between the two atoms. That's why it is having a location so called as a localized electron. I am telling the sigma bond is the strong bond. Are you agreeing or no? Sir, why? Okay, in case of sigma bond, the electrons are carrying a negatively charge and the nucleus are carrying a positive charge. So the electrons is lying on the internuclear axis, then the distance between electrons and nucleus will be less. Distance is lesser, force of attraction will be high. More force of attraction, more strong. That's why in case of sigma bond, yes, the electrons and nucleus of the bonded atoms are very close to each other. Because of that one, strong force of attraction is there. That's why you are getting a strong bond. That's why we are saying sigma bond is the strong bond. And we can tell some other things. It is an independent bond. Sir, what is the meaning of independent bond? Anybody? It's not depending upon any other factor. Means other bonds. Means between the two atoms, whatever first bond is coming, that is calling as sigma bond. Before sigma bond is there anything? No. That's why the sigma bond is calling as an independent bond. And the sigma bond can influence the shapes of the molecules. Shapes of molecules is affected by sigma bonds. Yes, different number of sigma bonds having molecules or having a different shape. That's why the shapes of the molecules is affected by sigma bond. And we can tell with respect to sigma bond, we can rotate the atoms. We can rotate the bonded atoms. Bonded atoms with respect to sigma bond. Sir, how it is? Yes, you take A atom is connected with B atom. Now they are connected with the sigma bond. Sigma bond is the strong bond. Yes, you fix A atom and rotate the B atom. Is it possible? Yes. Why? The sigma bond is the strong bond. That's why it will not be breakdown. This one, the rotation of the bonded atoms is possible when they are connected together through sigma. These are the factors. Just once you see, then we can go for pilot. Sigma bond is a covalent bond formed by overlapping of atomic orbital through its internuclear axis. Means the atomic orbital should be come on to the internuclear axis. What is the meaning of internuclear axis? Inter, in between, nucleus, means nucleus. So by joining the two nucleus, you have to imagine one line. On the line, the atomic orbital should be approached together. Then we are calling as internuclear axis overlapping, also called as head-on overlapping, or also calling as end-on overlapping. So this overlapping is giving a special covalent bond is calling as a sigma bond. And later this overlapping or sigma bond is formed by SS overlapping, SP overlapping, and PP overlapping. And sigma bonded electrons are having a particular location called as localized electron. The sigma bond is the strong bond because the distance between electron and nucleus will be less and force of attraction will be high. So strong bond. And they are calling as an independent bond. Independent bond is it will not depending upon other bonds. Itself it can form first bond is always sigma bond. And sigma bond is also influence the shapes. And we can rotate the bonded atom with respect to sigma bond because sigma bond is a strong bond. And now we are discussing about the second type of the covalent bond is nothing but a pi bond. How you are defining the pi bond? Yes, anyway. I will tell you, see, first of all, you take two atoms, A and B atoms, already they are connected together through sigma bond. Two atoms is there, already they are connected together through sigma bond. After that, on those atoms, some valence shell orbitals will be ready. For example, they are nothing but px orbital and px orbital. So what is the condition for the pi bond formation? Already two atoms were there, they are connected with sigma bond. After that, still the atoms were having some vacant orbitals or some atomic or some valence shell atomic orbitals is there. They are parallel to each other. Means if you can take sigma bond is here, is a px and px. Those two are parallel together and perpendicular to the which one? Sigma bonded plane. Yes, this is nothing but perpendicular. So they are parallel together and perpendicular to the sigma bonded plane. Then they are involved in a special type of the overlapping that is calling as not internucleus. they are calling as sidewise overlapping. The sidewise overlapping are also calling as lateral overlapping. The sidewise or lateral overlapping will give another covalent bond called as pi bond. Okay, the electron may come here or here because orbital means region in that at any way we can find out the electron. That's why the overlapping may upward or downward. So that's why like this overlapping we are getting a one pi bond we are getting. So now listen carefully. Pi bond. Pi bond is a covalent bond which is formed when already atoms are connected together through sigma bond. Then the atoms are having some valence shell orbitals on that they should be parallel to each other and perpendicular to the sigma bonded plane. Then they are involving in the sidewise or lateral or parallel overlapping will form a covalent bond called as a pi bond. How can you show that one? A, B atoms is already connected by sigma bond and one more bond we are getting called as pi bond. So now we have to go for some other concepts now. So how we are getting this one? So this pi bond is formed because of PP overlapping or PD overlapping or DD overlapping. So if you can take d orbital and d orbital, they should be parallel to each other and perpendicular to a sigma bonded plane. That's why PP and PD and the DD orbital overlapping gives a pi bond. After that we have to see one more thing. Between A and B atom, this is the sigma bond and pi electrons is there. The pi electrons cannot sit calm. Why? Because those pi electrons is away from the nucleus. A gap is more. Because of gap is more, attraction is less. Attraction is less. What happening? They are roaming or they are rotating above the sigma bonded plane and below the sigma bonded plane. So whatever pi electron will be there, they are maintaining much gap. They are not on internuclear axis. So whatever pi electrons is there, they are maintaining much gap from the nucleus. That's why the electron will be rotating above the plane and below the plane. That's why is it having any location? No. That's why the pi electron is calling as delocalized electrons. Delocalized electrons. Delocalized, no location. They can rotate above the plane or below the plane also. And the pi bond is calling as a weak bond. And sir, why pi bond is calling as a weak bond? Compared with sigma bond electron, pi electrons are maintaining much gap from the nucleus. More gap, less attraction. Less attraction, weak bond. That's why we are calling as a pi bond is a weak bond. And pi bond is calling as a dependent bond. And sir, why we are calling as a pi bond is a dependent bond? Yes, condition is what? First of all, the atom should be connected with sigma bond. Then only pi bond formation is happening. Means the pi bond formation takes place after sigma bond formation. That's why the pi bond is depending upon formation of the sigma bond. That's why it is calling as a dependent bond. And we can tell some other things is nothing but rotation of atoms. For example, you have A, B atoms will be there. They are connected with which bond? Pi bond as well as sigma bond. Okay, but if we can take with respect to pi bond, we can't rotate the atoms. Cannot rotate the atoms. Yes, why cannot rotate the atoms with respect to pi bond? So the pi bond is a weak bond. Now you take AB atoms like this, already sigma bond, pi bond is there. Now you are rotating the atoms. What happening? Pi bond is a weak bond. Because of weakness, what happening? The bond will be breakdown. Then is it possible rotation of atoms? Not possible. That's why the rotation can't rotate the atom with respect to pi bond. Why? Because while rotating the atom with respect to pi bond, what happening? The atomic orbitals are going away from one another. Definitely what happening? The bond will be breaking. That's why listen carefully. Pi bond is a covalent bond which is formed already connected by sigma bond. Then those atoms already having atomic orbital from its valence shell, they should be parallel to each other and perpendicular to the sigma bonded plane. Then they are involving in the sidewise or lateral overlapping called as pi bond. And this is formed because of PP, PD and DD overlapping. They are calling as a delocalized electron because pi electron will be rotating above the plane and below the plane. And they are calling as a weak bond. Why? Because they are maintaining much gap from the nucleus, that's why weak force of attraction, so called as a weak bond. And it is calling as a dependent bond. Why? Because after sigma formation only pi formation takes place. This is depending upon sigma bond formation. Next, if you want to rotate the atom with respect to pi bond, it's not easy, it's not possible, because while rotating pi bond is a weak bond, that's why bond may be breakdown, that's why rotation of atoms is not possible with respect to pi bond. Are you clear? Yes. Now, so always you have to write out sigma bond is the first bond and down, and upper bond is the pi bond. So much meaning is there. Why? Because sigma bond is a strong bond. Strong bond means less energy down below, and pi bond is a weak bond. Weak bond means more energy. That is the meaning. That's why in between two atoms, for example, only one bond is there, AB. That is nothing but a sigma. In between two atoms, two bonds is there, one sigma, one pi. Not like that. In between two atoms, we have triple bond maximum. One sigma, remaining two are pi bonds. Only one bond, sigma. Two bonds, one sigma, one pi. Compulsory first bond is the sigma bond. After that, all are pi bonds. Yes, between two atoms, triple bond is there. One sigma, remaining two are pi bonds. All of it clear? Yes. Now we will see some examples of how they are involving in the bond formation. First molecule I am explaining the formation of the ammonia NH3 molecule through overlapping process. Check it. Nitrogen, atomic number 7, configuration 1s2, 2s2 and 2p3. According to DVD, which orbitals are involved in the overlapping? Valence shell orbital with single electron. Valence shell orbital. 2s having how many electrons? 2 electrons. 2p are of how many types? 3 types. Okay, na? So first one electron goes into one orbital according to whom? Okay. From nitrogen, which orbitals are involving in the overlapping? Valence shell orbitals, but this is paired, not involving. This is involving, this is, and this is. So right now currently they are nothing but 2px, 2py and 2pz orbitals. P orbitals representation. Now right now that only nitrogen, around it we have 3p orbitals will be lying on it. They are nothing but 2px orbital, 2py orbital and 2pz orbital. Nitrogen is involving in the overlapping with hydrogen atom. Hydrogen atom means only one electron, nothing but 1s1. Okay, from nitrogen px, py, pz is coming, but from hydrogen which is coming? S orbital is coming. Yes. Now this is the nucleus, this is the nucleus. By joining those two, we are getting the internuclear axis is coming. The nitrogen atom of the p orbital, hydrogen atom of the s orbital coming around the internuclear axis, then overlapping is takes place, that is calling as sigma bond. Internuclear axis overlapping is calling as a sigma bond. I will show that one here. Nitrogen and hydrogen bond formation with sigma, that is nothing but sp overlapping, s of nitrogen, p of hydrogen. Now you take one more 2py orbital, one more hydrogen atom of the s orbital is coming to its internuclear axis only. Also involving in the head-on or end-on overlapping gives sigma bond. Same situation here also, hydrogen atom of the s orbital coming to its internuclear axis will be happening like this. Then we are getting sigma bond. So like that, around nitrogen we have 3 bonds we are getting. So sigma all are which overlapping? sp overlapping, sigma sp overlapping. So after that we can write one pair on it, that is calling as a lone pair. What is the meaning of lone pair? A pair of electrons which are present in the valence shell but not involving in the chemical bonding, that will be called as lone pair. Yes, he asked the question, in ammonia, how many bond pairs are there? 3 bond pairs. And how many lone pair? 1 lone pair. Did you got my point? Yes. Now, we are taking one more is nothing but H2O molecule amount. H2O molecule. Yes, you take oxygen, atomic number 8, configuration 1s2, 2s2 and 2p4. Generally, from the molecule, which orbitals are involving in the overlapping according to VVT? Valence shell orbital with unpaired electron. Now, valence shell orbital means the last shell, 2s, 2p. 2s is having how many types of one type but having 2 electrons. 2p are of how many types? 3 types. Okay. Now, how is the filling? First one goes into each orbital according to rules, then only pairing takes place. Tell me, according to VVT, which orbitals only involving in the overlapping? Unpaired electron having valence shell orbital, but these two are not involving in the overlapping even though present in the valence shell because they are paired. Now, which orbital will be there? 2py and 2pz. And 2px is valence shell but paired. Okay. Now, you can take, combining with which one? Hydrogen 1 and 1 is 1. Oxygen has how many p orbitals on it? 2 p orbitals, 2py and another one is 2pz with the which one? Single electrons. Okay. Now it is approached with which one? Hydrogen. How? Through its internuclear axis. Internuclear axis overlapping gives sigma. Yes. Now, same situation here also, hydrogen is coming with s orbital with single electron, then they are approaching together to its internuclear axis, we are getting one more sigma. Write down this one clearly, oxygen, one side hydrogen, this is the sigma bond because of sp overlapping, that's why I give an example under sp overlapping. After this, all oxygen have to write down how many pairs? 2 pairs. Because the pairs which are present in the valence shell but not involving in the bonding, we are showing them as a lone pairs. Just I will tell you some other molecules. I will tell you. Listen carefully. This is a third molecule, nothing but oxygen. Just now we learned from oxygen. Yes, what is the situation? 1s2, 2s2, 2p4. Okay, these are only you have to show it. 2s is having already paired. 2p are of how many types? 3 types. But we have paired and 2 are unpaired. Now this is the 2px, 2py and 2pz. From oxygen, which is involving in the overlapping? 2px orbital and 2py orbital. Another one is also oxygen. I will show same thing here. This is, like this I am taking. One is 2pz orbital, another one is 2py orbital. Right now they are having single electrons. Same situation combining with another oxygen. No, there also same situation will be there. They are nothing but 2pz orbital and 2py orbital with unpaired electrons. Now, the two oxygens are approached together to its internuclear axis, then head-on or head-on overlapping which takes place gives sigma bond. So, between oxygen and oxygen, sigma bond formation is over. Condition. After formation of the sigma bond, only chances for formation of the pi bond. To form the pi bond, condition what? After forming the sigma bond, the atomic orbital should be parallel to each other and perpendicular to the sigma bonded plane. That's why 2py, y-axis. Parallel to each other. Yes, that's why they are involving in the sideways overlapping, will forming a pi bond. So can you write this one as a pi bond? Yes. So in O2 molecule, oxygen connected together through double bond, one sigma bond and one pi bond. After that we can write on each oxygen, this is a lone pair, this is also lone pair. Can we show them as like 2 pairs? Is it? Now, I will give you one more example, is nothing but the N2 molecule. See carefully. Yes, you take nitrogen is there, atomic number 7, configuration 1s2, 2s2 and 2p3 will be there. Already we know. Just you see, already we know from nitrogen S and p orbital. Yes, S orbital is already